Hello everyone. So we are starting the Big Data Analytics course, which is the part of the Computer Science and Engineering AI/ML branch of BE for Osmania University. We are starting the introduction in this session. So my name is PVN Balramurthy. I'm the assistant professor in NGIT, and I'm the Hadoop certified professional with 5 certifications, international certifications from HotOnWorks. So we will start with the course content and the background for this course. So here in this we are going to discuss about data, characteristics and existing systems and problems for the big data, and what is the Hadoop, and then Hadoop ecosystems, and then we will discuss about the prerequisites, and then we will discuss about the content of this course. So let us start with the big data concept. Nowadays there are so many sources for generating the data. So the number of the data is increased a lot from last number of decades. It may be from last 4 decades. The data was increased a lot. So it crossed the GBs, gigabytes, and then terabytes also. And now the data has become petabytes, exabytes, zettabytes, and yottabytes and brontobytes also. Of course, there are so many other units also there to measure the data. Now we are going to deal with the petabytes of data, how to handle the petabytes of data and exabytes of data by using the big data analytics. So now if you have number of this much of data is generated, then how can we handle this data? Where should we store it? Even if we are able to store, how can we process? Is it possible to process the data? And can we use the centralized servers? We have the centralized server. There will be a large machine available, and which can be handled to store the data and also to process the data. Is it possible to handle with a single server? And how to recover the missing data if that server is down, if the server is crashed? Then what can we do? Meaning that, can we get the missing data back? For all these questions, Hadoop is the solution. So we are going to discuss with the Hadoop environment. Now let us start with the sources of the data. What are the sources of data? If you say this, here you can observe that within a minute of the day, in the YouTube, if you see the YouTube, 72 hours of video is getting uploaded in 1 minute of time. So this is a simple example how much data is generated, and those are number of emails are generated, and number of Google searches, and Facebook shares, and tweets, and so many downloads, and all these are the data sources which are generating the data. So how to handle this much of data? Now what is this called? We can call it as the big data. Now can we consider this as the big data? If it is having the huge amount of data, can we consider this as the big data? No. Actually, the big data means not only about the size of data, it is about the value also inside that data. So the big data can be characterized with various characteristics. Basically, there are 3 characteristics available. That is the volume, variety and velocity. And then value was added by IBM, and later on number of V's are added, and there are almost 11 V's are introduced as the characteristics of the big data. But in this course we are going to discuss about only 5 characteristics: volume, variety, velocity, value, and also the veracity. And now we will go with the big data concepts. Now another definition is also there, that is the data which cannot be processed by using a single machine, that is also called the big data. So this is another way of big data definition. Not only for the storage, processing, if you are not able to process by using a single machine, then it is called the big data. Now What are the characteristics? Let us have a look on them. So big data is having the volume, velocity, variety, value, and also the veracity. These are the 5 characteristics of the big data. Volume represents the huge amount of data, very large amount of data, and velocity means access speed. Access speed, that means the if you give the query, that has to be processed very fast and you have to retrieve the data quickly. Okay, and you should be able to upload the data very fast. So that is also the velocity. And variety, different kinds of data should be handled, meaning that the data may be in different formats, that may be in the database format or in the file format or in the XML format, JPG format, or whatever the data. It has to handle all kinds of data. There is a variety of the data. And value. The value comes in two areas, meaning that if you are able to represent the data in the numerical format, then there is the value. If you are able to process the data, then there is the value. And if the data is relevant to your business statement or problem statement, then it comes under the value. Otherwise, there is no use of that data. Now, veracity. Veracity means since it is generating large amount of data, there may be the noise or unwanted data. So, the big data is responsible for reliability of the data also, meaning that the noisy data has to be cleared. So, there are some techniques for clearing that noise also. So, these are the basic characteristics of the big data. Now, let us go with the how to handle this much of big data. Is it client-server architecture? Is it possible? Definitely not. Because, of course, three-tiered architecture is also there, but by using three-tiered architecture also we cannot. Why? Because the client-server architecture is having one server and number of clients. The server is responsible for storing the entire data, and it is also responsible for processing of that data according to the requests from the available clients. So it is the server is overloaded. The server may be overloaded. I think you may experience that at the time of results. If you get the results are out, then the server may be down. You may not get the results immediately. You have to wait for some time. Why? Because the overloaded, meaning that there are some problems, that is single point of failure. Once the server is down, these two are dummy. You don't have anything. Only the server is holding the data and it is only processing. So single point of failure, and server is overloaded. It may be overloaded and it requires high configured machine also. So it is expensive. So these are the problems with the client-server architecture. Of course, even the three-tiered architecture, the server is divided into two parts. So one server is the file server and another server may be the application server, so that at that time also these problems are still there. So because of that reason, we have to go for other solution. What is the solution for the big data? Distributed system is the solution for the big data. So what are the distributed systems? What are the components? And what are the various areas of the distributed system? Majorly there are two areas: distributed storage and distributed processing. These are the two major areas in the distributed systems. So we are going to concentrate on them. Now, distributed systems. What are the distributed systems available? Google. Google is the best example for the distributed environment. So the Google has the servers all over the world, and they are interacting with each other, and they are working as a single server. So this is the distribution of distributed system. This is the one of the example for distributed system. Actually, they only introduced the distributed file system, one kind of distributed file system, that is GFS, Google File System, and distributed processing environment, distributed processing paradigm, that is called the MapReduce. These two are introduced by the Google only, and inspired by that concept, actually those concepts are only the Google property, so only the Google products can use them. So they published some papers on the GFS and the MapReduce. Based on those papers, in some other organization, the open source software was developed for the distributed environment, that is the Hadoop. It is an open source environment. Right? Now, what is the Hadoop then? Here, the Hadoop is the open source software framework. Please remember that it is a framework for distributed storage and the processing of the data set of big data using the MapReduce programming model. So this is the standard definition for the Hadoop. So it is having the storage and also the processing in the distributed manner. And what are the basic components of Hadoop? The basic components, actually it is a framework. Framework means it is developed on top of some other language and you have to implement it more. So it is a framework. It is developed on top of Java. Now in Java, the basic idea is distributed environment means the data has to be distributed into number of machines. So we should, the Hadoop should provide the environment to communicate from one machine to another machine. That communication can be done by RPC, remote procedure call in Java. So that can be done and all those components are packed into one component that is called the core Hadoop. And if you want to store the data, we should have some file system. That file system was also implemented in the Hadoop as the HDFS, Hadoop Distributed File System. And for processing of the data, MapReduce, distributed processing of the data by using the MapReduce component. And advanced version of the MapReduce is the Yarn. So these are the four basic components of the Hadoop and we can achieve the distributed environment by using these four components. Of course, there are some other components are there. They are called the ecosystems. Now, let us go with the history of Hadoop, how it was started. As I mentioned, it was started from the GFS, Google File System, and the MapReduce concepts by Google. Now, it was taken in the Apache. Actually, there was the Apache Nudge project, and he is the dog cutting. He is the member of that Nudge project, and he needs to develop the search engine, high-level search engine for on the huge amount of data, so that he has to build his own file system and the processing environment on the distributed environment. So he designed the Hadoop. And he has given the name that Hadoop with the HDFS and the MapReduce. And he joined in Yahoo and he continued his research and he developed all these components. And Hadoop was developed by number of companies, number of organizations, and major organizations are Cloudera, Hortonworks, Yahoo, and LinkedIn, and also some other the popular organizations are LinkedIn, Facebook. All these are also contributed in the Yahoo development. So we can continue in the next session.